Hi, my name is Dr. Julie Fietta. In today's video, we're going to be talking about Alzheimer's disease. This is a condition that is typically associated with dementia, but they're not necessarily one and the same. While Alzheimer's disease is the most common cause or type of dementia, there are other forms that can occur either with or independent of Alzheimer's. For example, frontotemporal dementia, Lewy body dementia, or vascular dementia. For the purposes of today's video, we'll be talking specifically about Alzheimer's disease. Just a note, I will be referring to Alzheimer's disease interchangeably with the acronym AD throughout this video. So before we understand how Alzheimer's disease impacts our brain's function, we first have to understand a little bit more about how the brain functions without AD. Now, the brain is essentially a massive communication hub. Signals are sent, processed, and managed at incredible speeds. Things like what we see, hear, taste, touch, these are all incoming signals that are managed by the brain. And then purposeful movement or talking, those are signals coming out of the brain, directing our bodies and how to interact in day-to-day life. The signals that are sent throughout the brain go along pathways that are made up of brain cells called neurons. The signals or messages, or rather messengers, are called neurotransmitters. Now, some neurotransmitters are excitatory, think the on switch, while other neurotransmitters are inhibitory, think the off switch. Both excitatory and inhibitory neurotransmitters are important in different brain function. Too much or too little of either one can cause issues. These neurotransmitters move down one neuron and onto the next. They more or less jump a space between the two brain cells. This space is called the synaptic cleft. The process by which neurotransmitters are actually propagated throughout the brain or along the pathways in the brain is incredible. We won't go into great detail today, but there is one more component of the brain I want to talk a little bit more in depth about. As we learn and grow, especially in the earlier parts of our lives, we develop new pathways. Some are used more extensively than others as we practice something or play something again and again in our minds. These well-worn pathways become memories. A key component of the brain when it comes to making memories is called the trisynaptic pathway. This involves several different types of neurons linked at synaptic junctions. 3 synaptic junctions to be specific, hence the name trisynaptic pathway. The trisynaptic pathway processes short-term memories until they can be stored in other regions of the brain as long-term memories. The trisynaptic pathway is housed in a special component of the brain called the hippocampus. The hippocampus is located in the temporal lobe. Now, this is a very high-level and simplified overview of how the brain works. I say that to emphasize the complexity of the brain, a complexity that seems to make it both resilient and vulnerable. And that brings us to Alzheimer's disease. To begin, let's talk about the pathophysiology of Alzheimer's disease. What actually changes in the brain? Let me explain where we see changes in the brain. Remember the hippocampus, where the trisynaptic pathway is found, where short-term memories are processed so that they can eventually be stored as long-term memories, often in other regions of the brain. With Alzheimer's disease, we see these brain changes starting in the hippocampus and then moving out throughout other regions of the brain. So somebody in the earlier stages of Alzheimer's disease, or AD, may be able to remember something that happened 50 years ago, that long-term memory, but they can't remember something that happened 5 minutes ago. It's a short-term memory. We see several different types of brain changes. We see atrophy. So if you know somebody who's worn a cast, let's say on their right arm, you might know that after that cast is removed and they haven't used the muscles in that region for an extended period of time, you'll actually see shrinkage in that area. So the right arm that had the cast on might be smaller than their left arm that they've continued to use. This is called atrophy. That's atrophy of the muscles. With Alzheimer's disease, you see atrophy of the brain. So somebody with Alzheimer's disease may actually have a smaller brain than somebody of the same age without AD. You also see buildup of neurotoxins, things in the brain that shouldn't be building up there. We see on the outside of the cell or in the extracellular space something called amyloid beta, and you see that pictured here. And then in the intracellular space or inside those brain cells, those neurons, you'll see tau. And you'll see the tau tangles pictured in this image. These images are from the NIH. So you have that extracellular amyloid beta and the intracellular tau or tau tangles. Now, if you're aging, even if you're healthy, you're probably building up amyloid beta in your brain, even if you're not that old. This is something that just happens as we age, but it builds up more or reaches pathological levels with Alzheimer's disease. Now let's talk about the clinical presentation of AD. This is more what you see on the outside. One of the hallmark symptoms is a change in memory. As I alluded to earlier, you might see more of a change in short-term versus long-term memory, especially in the earlier stages of the disease. There are other facets to the clinical presentation though. One is communication. So your loved one may have difficulty keeping up with the conversation or clearly communicating their thoughts. We did make a video on communication hints and tips. I'll put a link to that video in the description of this one in case this is an area where you need additional support. Another component of the clinical picture is changes in behavior. Your loved one may experience agitation or even paranoia as a symptom of this condition. You're probably going to see changes in day-to-day function as the disease progresses. So more complex tasks like cooking a meal, driving somewhere, or even getting ready for the day. These can become more difficult for somebody who lives with AD. That's where caregivers often step in and support their loved one. My hope is that this video was educational, but not discouraging. If you're concerned about your risk for developing Alzheimer's disease, please know that there are a number of steps you can take to support healthy brain aging. Things like diet, exercise, and sleep health all really make a difference. So I encourage you to talk to your primary care provider. Perhaps you're an Alzheimer's disease caregiver. If you're having difficulty supporting your loved one in any of the areas that we talked about today or otherwise, I encourage you to seek support through your healthcare provider, perhaps a local Alzheimer's Association chapter, or a peer support group, in person or online. That said, please remember, nothing in these videos should ever be taken as medical advice or recommendation. I'm not that kind of doctor. Thanks for watching. Please like, follow, and subscribe.